Hello, my name is Miloš Milutinović and I'm a product manager at Embedded++. In this video, I'll present you key technical specification of the EPP Pico OMAP5 single board computer, and I'll shortly demonstrate you how it runs Android and Linux. So let's start with the size. Please note that this is a very compact design. Actually, all logic, integrated circuits and connectors are placed on the board, which easily fits into my hand. Actually, it is a Pico-ITX form factor with dimensions of 100 x 72 mm. Total height of the board is less than 20 mm, which could easily be reduced using low-profile connectors for applications which require that. On the performance side, the board is driven by high-performance multimedia application platform OMAP5 from Texas Instruments. It is a very powerful system on chip with numerous of advanced subsystems. First of all, there are two ARM Cortex A15 cores, then DSP 64X subsystem, HD image and video accelerator, image processing unit, 3D graphics processing unit, and many others. One of the most interesting features is a face recognition module. Actually, it is very important to mention that this board is supported by up to 2 GB of low-power DDR2 memory. With its compact form factor, very low power consumption and extensive set of software features, the new EPP Pico OMAP5 single board computer perfectly suits ultra small and ultra mobile applications. Target applications include set-top boxes, intelligent camera and medical applications, mobile HMIs, kiosks, as well as gaming and gesture control devices. Before we start with the software, it is very important to mention that this is fanless design with very low power consumption. Maximum power consumption of the board is less than 4 watts and typical power consumption is about 2 watts. When it comes to power, this device is very flexible. First of all, it accepts a wide input voltage range from 4.5 to 18 volts, but there is also a built-in battery charger supporting single-cell lithium-ion batteries, which makes it perfectly suitable for portable applications. When it comes to software, currently we are providing BSP support for Ubuntu 12.04. In future, you could expect BSP integrated in the Yocto project, so you can create your own custom Linux distribution. Also, we will provide BSP support for Android Jelly Bean and future Android releases. What I want to say is that this board is fully compatible with Texas Instruments OMAP5 EVM development platform, and any application developed on that EVM platform could easily be ported on our board. In the next couple of minutes, I'm going to present you how this system runs Linux and Android. I'll start this demonstration with Linux. Please note that we are now using Ubuntu 12.04. First of all, I'm going to set up a debugging console. This is a UART console over USB. I'm connecting it. Now I'll put in SD card with operating system and I'm powering up the board. Before that, of course, I have set up deep switch on board to boot from SD card, and I have prepared the SD card with operating system. You can see 2 penguins on my monitor, and we are now expecting console prompt. I have debugging console on my PC too, and I will use it for entering the commands. I'm typing root to log in, and here it is. We can now start some graphic demos. This is accelerated HD video decode using kernel mode setting.
You may notice how the video is going very smoothly. Okay. Now I'm going to show you accelerated HD video decode into Metacity Window Manager. Here it is. So how you can see, I can easily restore, resize, maximize or even close the window. Next demonstration would be spinning cube with video. Okay, this is the accelerated 3D video decoding, and you can see white looping into the rotation cube. In 4th demonstration, we'll use the web browser. Here it is. This should be HTML5 video played into the Chromium web browser. Here it is. It goes very smoothly, and it will be all. Let's continue with next demonstration, which is actually the most required test. In this test we are doing decoding, encoding and again decoding of video that is run in this window frame. As you can see, it runs in real time, and in the next release of the processor it will be even faster. At the end we'll show you Wayland graphic environment. Wayland is a new desktop compositor for Linux, and it is intended as a simple replacement for X, easier to develop and maintain. Now I can type commands in Wayland. For example, we can shut down the system because we'll continue with Android. That's it. Before we start, we have to upload Android OS images into the eMMC memory and configure a deep switch on the board to boot from eMMC. I have already done that, so we can continue. Okay, I'll power on the board and Android should be started. It takes a few seconds. Yes, that is Jelly Bean boot animation. Okay, I need a mouse to unlock this, and I'm getting in. Now I'm going to menu. This is a classic Android user interface, and I'll, for example, open settings and show you something interesting. Certainly you observe the module, and here this is the slot where we can place module with Wi-Fi, Bluetooth, FM or GPS capabilities. So for this demonstration I will use Bluetooth. I can turn it on and search for devices. Okay, this is my colleague's phone and I can pair with it, or I can enable Wi-Fi and search for my network. Okay, This is the network shared for my phone. It remembered the password, so it is now connected, and now we have internet and can play something, for example on YouTube. Here it is. Can play, for example, this one. So HD video is turned on, video is going, sound is going as well, so we can shut down this and go back. I'll go back to menu and start, for example, 3D cowboy application from Texas Instruments. So here I can zoom out or zoom in, or even increase the rotation speed. That would be all from Android. Thank you for your attention.